Hi viewers, and welcome to the channel, and today we're looking at a viewer's question. Now she has asked about a scissor lift problem, and it's all down to topological naming issues. I can demonstrate that in this model here. Now what's happening is we've got this first part of a scissor lift. Now a scissor lift is basically, if you think of these two parts duplicated up all the way up, and we pull one in, it will scissor the whole assembly up and down. And what's happening is that we're coming into the skeleton. So this whole assembly is driven by this skeleton here, which is basically a scissor. And when we duplicate up this skeleton, for the next part of the scissor, so I do Control C on that, and I've got a spare point there. Let's get rid of that a minute. Don't need that. So when we duplicate up this skeleton, Control C on that and move it up, and I'm going to auto constrain it to that horizontal line there. That's fine, so we're okay there. You can see that hasn't changed at all. But the minute we connect these points up here, so I'm just connecting these points here and using point on point constraint for those, and the same with this one. Watch what happens. The minute we close this, this one has moved. Before that was across here, and now this is moved up here. And this is because of topological naming issue that plagues FreeCAD. Now, you've probably heard of this before. If you're a newcomer to FreeCAD, it can be a bit off-putting. And FreeCAD developers are trying to get rid of this. They're working quite hard to get rid of this, because I believe once this is gone, it will open up FreeCAD and there will be a lot more users that will be using it and adopting it for their needs. What actually happens is that FreeCAD will optimize a model depending on the different faces that are in there. So this can happen with faces and pads, lines, edges, etc. So if you have pad 1 with pad 2 and then a pad 4, FreeCAD may end up optimizing pad 4 to become pad 3 and rename it. But if you've got parts relating to pad 4, then they may break. So you get this problem of renaming. That's exactly what's happening here. So I'm going to Control Z that and break that, so that's back down to where it was before. And let's have a look at what's happening with the skeleton. So we haven't got these two attached. And you see, the minute we attached it, this jumped to this line here. This is the problem that the viewer's got. He's having this problem here. If we look at how these attach, so these parts are attached by something called a local coordinate system, or LCS, and there's that there. I'm just going to hide those parts. So we're concentrating on this skeleton here, so this master sketch here. And you can see we've got arm 1, which is an LCS system, so I'm bringing it in and out of existence there, so you can see it there. And arm 2, which is the same, and that's in line with this line here. And you can see the LCS system is just sitting there. So red's pointing up that way, green that way, and the blue is in line with this line. And this is arm 2 for arm 2 LCS. So let's have a look at arm 2 and see what it connects to. So arm 2 is connecting to sketch edge 2 of the skeleton, which is, if we hover over, we can see that sketch edge 1. And this one here is sketch edge 2. So that's right, that's connecting there. Arm 1 should be connecting to sketch edge 1, which is this one here. So we've got edge 1 and edge 2. The minute we introduce a new line or copy this and try to connect it to this point, this is when the topological naming issue comes into effect. It actually renames this edge here and moves that edge up to this point. I'll show you that. So we don't even need to demonstrate that with a copy of the skeleton that I want to copy up. So let's get rid of that. If I just place a line along here, you watch what happens. So place a line here, connect it to that point, so the auto constraints are on, so it's connected to that point, and we'll just place a line there. And hit escape. And you can see, even when I'm in this sketch, if I hover over here, that's edge 1. This one is edge 3, so that doesn't even have any continuity with what we have when we come out of this. And this one is edge 5. The minute we hit close, all looks well. Let's bring back in our arms. We can see our arm has moved up there. And this one. But looking at the LCS system, you can see arm 1 is still edge 1 and arm 2 is still edge 2. But if we look closer, so let's move this one that's moved up. If we were over that, you can see that same skeleton sketch edge 2. So you look down the bottom, if you roll over, so you cast your eyes down to the bottom, you see that skeleton edge 2. This one has been renamed to skeleton edge 3. So obviously the one that this sits on is edge 1. So it's kind of optimized the naming, so we're going edge 1 to edge 2, and this is just because we've made a connection here. If we go back in, let's bring those arms back. If we go back into our skeleton, let's break that connection there. Just hitting Control Z on that, so that's broken that connection there. Close that. You can see that's back. So the minute we make that connection again, point on point constraint, close that, and then it's moved. So the literal process of making that connection, so if I delete that, then that's moved away from that connection. Let's close that now. You can see that's back to normal. So the minute we make that connection, it starts renaming because there's a link between those two. Now the way to resolve this is by using some other type of geometry to actually connect these together. And it's actually pretty simple, because if this line here I wanted to connect to here, instead of doing a point-on-point constraint and creating the topological naming problem, if I connect this point to this line with a point on object constraint like so, if I close, then we don't get this problem. And we can just create another constraint between these two. So these 2 points here, stick a distance constraint in, or a length constraint, and just stick it to something like 0.5. Then we fixed our issue. So as simple as creating a simple constraint in there that's different from point-on-point constraint, we create the effect that we want. Now you don't have to use that kind of constraint if you don't like that kind of constraint. We could use, for instance, let's delete that constraint there. We could use something like a piece of construction geometry. So if I place a line that connects that one and that one, then we should receive some problems on the other side. So let's go back in and let's try making that a piece of construction geometry. So I've clicked on that. Let's come up here and use the toggle selected geometry to construction geometry and close that, and it's back to where it should be. And we could just come in here and just make those parallel to each other and just put some kind of arbitrary length in here, again like 0.5 millimeters, and close that, and we've solved our problem. Now one thing you would notice also if you're looking closely is that you see I've got a point here, and there's a reason for that as well, and that is because of the topological naming issues. I'm just going to get rid of this piece of construction geometry. And you see that this line is basically made up of a line, like so, and then I use a point on there. Now it's not often that I create a point on the sketch, but this is handy for connecting other items to it and stopping the topological naming issues. So let's create that point on there. See, it's a point on object constraint that's automatically constrained to there, and that means that we won't get the problem, or it should limit the problem anyway. And what I would do is take this length, set as a length of say 100 millimeters, and then making sure that one's in the middle, we could use a symmetry constraint by clicking those two and clicking that middle point and doing a symmetry constraint on that, and that's placed it in the middle like so. Or like I've done here, I've used a constraint of a length which is half of this one, so I can place a length in there and make that 50 millimeters, or even come in here and assign it a function. That's if we've named this length here, say to arm length, then I can come in here and use a function in here, constraints dot, there's already a dot in there, so we can go arm length in here, and you can see the result is 100 millimeters, and just divide it by 2. Okay, that, and okay, that. So that's got, you can see that's come up in orange, that's referenced constraint, it's referenced to there. So as long as you constrain that 50 millimeters away, and what that does is, if we used a normal polygon like this and made those two equal, and used a parallel constraint on those like so, and assigned a length to this, if you look down the bottom, if we roll over, that says skeleton edge 7 and edge 8. So we've got a problem here because these are two different edges. With this one, it's just one single edge. So what will happen with our topological issue is that our part will sit on here and it will jump to this part here. So it's best to place a point in the middle of there rather than using two lines like this in a polygon. It would be more logical to do this, but this will save the topological problems or limit them. So that's how that's built. Now what we need to do is create a scissor lift all the way up here. So I'm going to copy this. So I've copied this, it's highlighted in green. Hit Control C. You can see this line's connecting to the center. That's an auto constraint, so I could automatically constrain to this line, which is constrained to, for so desire, or I could place it over here and constrain that to that line. Now this is where our connections come in. If I connect this one to this one, then we're going to get the topological issues, and that's going to jump to there, as we saw before when we place that one onto here, constrained, closed, and then we jump, we get that jump. So to stop that, come back in, undo that, we'll take this point and this line and use the fix a point on an object. Let's fix on that object there. Let's come in here, and that doesn't look like it's actually on there, but it is. There you go, so you can see it's on there. And we need to take this point and this point and put a length constraint in and make that something like 0.25 or 0.5, and that will place that close to that point, but it won't connect it. So when we go back now, hit close, you can see the problem's disappeared, and we can start placing these arms along these lines here. So we can create some more LCS systems for this line here, and I'll just do that now. So jump into the LCS, and we're going to create a new coordinate system. There's arm 3, and I'm going to use this line, and I've just used the inertial CS there. Let's place it on there. Okay, that, and then I can import my arm and place it along there. So we'll import the yellow arm, which I believe is sketch scissor arm part rather than scissor arm part 001. So that's click on the model, import. So I'm just going to select the correct arm part, which I believe is this one. Insert that, and we're going to select the LCS on the left hand side, come over to the skeleton, arm 3, and we need to rotate that as well. There we go, that's rotated, and place some offset. No, we don't need any offset, so that's fine. Okay, that, and we can see that's in place now, which is perfect. That's exactly what we want. And we can go in here and create another one, and we must remember to connect out that part as well to this line. There we go, so that's there. And because we constrained the other side and the lengths are the same, we don't need to put a constraint for the length on there, because that will stay there. So that's good. So that's all there. Let's close that, and you can see that's all working fine now. So we can just add another part to here. So there you go, so that's 4 parts on there on the scissor lift skeleton. Let's double click the skeleton and move this. Close that, and you can see it's all working fine. Obviously we would control this with something like a length in here and attach this length to a variable. So if we come over and create a variable in here and add a variable, and we're going to say extension length, I say, and just going to copy that. That variable's in there, at the moment it's 10, and we can link this part, this length, to functions, and look at variables, and in here extension length, close that. That's a bit too much, so let's bring the variable down. that's controlled by that variable now, and we can place in our animation if we so desire on whatever variable we want. Extension length, beginning range of 30 to 75, or say 80, steps to 2, and we can see that we can run this animation. Hit run, and that's our scissor lift working. So I hope that's helped. There's going to actually be a tutorial of building the scissor lift on my channel shortly, and that's going to take you through start to finish using Assembly4, connecting up the skeleton, creating the parts, doing the variables, etc, etc. And that's going to be quite short because it's pretty easy to do, but there's a few gotchas, especially around this topological naming issues. And this is the same for everything in Assembly4 that uses the top-down approach, so you're using a master sketch to drive the animation rather than the bottom-up where you're connecting parts to drive the animation. Okay, so I hope you enjoyed, and I'll see you again soon. If you like what you're seeing, please subscribe to my site, and also I have a Ko-fi site. You can actually donate a few pence or a few pounds, dollars, or whatever your currency is, and that's at ko-fi.com/mang0, and there you'll be able to help me fund my site, and all the money that I actually get from any funds will actually get pushed back into the channel. Thanks a lot for watching and subscribing. I'll see you next time.